Hi everyone, in this video we are going to discuss this problem called cycle length queries in a tree. So the problem says that we will be given with an integer n which is representing a complete binary tree having nodes 2 power raised to n minus 1. These many nodes we will have in a complete binary tree. Okay, and the problem says that 1 will be the root and every left child will have a value of 2 into the value of parent and the right child will have a value of 2 into the value of parent plus 1. For example, for this one, the left child will have 2 into the value of parent, which is 2, and the right child will have a value of 2 into the value of parent plus 1, which is 3, right? And so on. We can build the entire tree, right? And we know that the number of nodes are going to be these many. Okay, so if we just try to build one more level, then the left child of 2 will be 2 into 2, which is 4, and the right child will be 2 into 2 plus 1, which is 5, and the left child of 3 will be 2 into 3 6, 2 into 3 plus 1, which is 7. Okay, and so on. We can build the tree further. Okay, now the questions further says that we will be given with m number of queries where each query will have two integers, let's say a and b. Now in this query, these two numbers will represent an edge between these two numbers. Like right now we have a tree, and for a given query we will have two values. For example, let's say we have 4 and 3. Right, now this 4 and 3 represents that we will have to generate or create an edge between node 4 and node 3, right? And now what we have to do is, now we can see that it will create a cycle, right? And now we have to find out the length of this cycle. What will be the length of this cycle? This is what we have to return for a particular query, right? So this is what question says. Now let's try to take some example and try to see how we can approach this problem. So let's take n is equals to 3, and let's say we are given with 3 queries having values 5, 3, 4, 7 and 2, 3. Okay. So for first query, we have to connect 5 and 3, right? And if we just connect these two nodes, we will have a cycle. Now we have to find out the length of this cycle. So what is the length of this cycle? Can we say that the length of this cycle is 1, 2, 3 and 4, right? We are assuming that the number of the length of a cycle will be equals to the number of edges that we will visit. So for this cycle we are visiting 4 edges. So the length will be 4 for this query, right? Now let's talk about the second query. In second query we have to connect 4 and 7, right? We have to connect 4 and 7. If we just connect these two nodes, again we have a cycle. So what is the length of this cycle? One edge, second edge, third, fourth, fifth. So we have 5 edges. So we can say the length will be 5 if we connect 4 and 7. Alright. Okay. Now let's talk about third query. So in third query we have to connect 2 and 3. And if we just connect these two nodes, we have a cycle of length 3, right? Because we have 3 edges. So the answer for this query will be 3. Now what we have to do is we have to return a vector containing the length of cycles that we got from these queries, right? So we have to return a vector containing these 3 values. So this is what we have to do in our problem statement. So now let's try to think that how we can approach this problem. So if we just look at the first query, which is 5, 3, if we connect these two nodes, then can we say that the number of edges will be equals to the number of nodes that we will get in a cycle? Like if we take any cycle, let's say we have these nodes, right? So if we are getting a cycle, then we can say that the number of nodes will be equal to the number of edges that we will encounter. So we can also say that the length of our cycle will be equal to the number of nodes that cycle contains. So we have to find out the number of nodes that we will have in our cycle. So how we can do that? So now if we just talk about the first query where 5 and 3 is connected. So in this case, can we say that the length of the cycle will be nothing but the length from 1 to 5 plus the length from 1 to 3. Like from 1 to 5 we have 1, 2 and 5, these 3 nodes. And from 1 to 3 we have 2 nodes, 1 and 3. So 1 we have already included, so we will just include 3. So we can say that we have 4 number of nodes. So we can say that the length will be 4, right? Similarly, if we connect 4 and 7, if we connect these two nodes, then can we say that the length of this cycle or the number of nodes that we will have in this cycle will be equals to the number of nodes that we have from 1 to 4 and the number of nodes that we have from 1 to 7. So from 1 to 4 we have 1, 2 and 4, right? Then from 1 to 7 we have 1 we have already included, so 3 and 7, right? So we can say that now we have 5 number of nodes in this particular cycle, right? Similarly, if we talk about third query, which is 2 and 3, so if we just connect these two, so we can say that the number of nodes in this cycle will be equals to the number of nodes that we have from 1 to 2 and 1 to 3. So 1 to 2 and 1 to 3. So we have 3 number of nodes, right? Now for a generic case, let's say for node A and B, we might be tempted to say that the answer will be the number of nodes from 1 to A plus number of nodes from 1 to B minus 1, right? But will that be really true? Let's take one more example. So let's say we are given with one more query, and in that we have to connect, let's say 4 and 5, all right? So we have to connect these two nodes, right? So now how many nodes we have in this cycle? So we have only 2, 4 and 5. So we have only 3 nodes, 2, 5 and 4, right? So we have only 3 nodes. So in this case we can't say that the answer is the number of nodes from 1 to 4 and 1 to 5. And why is that? Why is this happening? So this is happening because the definition says that we can't include the same edge multiple times. For example, if we go from 1 to 2, then we have included this edge. Then we will go from 2 to 4 and from 4 to 5 and from 5 to 2. Now to complete cycle at 1, we will have to move from 2 to 1. In that case, we will include this particular edge more than once, right? So that's why we can't say that, we can say that this will not be a valid cycle. Okay, this will not be a valid cycle. This will be a valid cycle, 2, 4 and 5, right? Cool. So in this, can we say that our answer is dependent on the lowest common ancestor? Our answer is dependent on lowest common ancestor, and that makes sense, right? Because let's say if we have LCA at a particular, like a node is LCA, then we have, let's say, A here and B here, right? So we can find out the number of nodes that are present between the path from LCA to A, right? Then we can find out the number of nodes between LCA to B, and A and B are already connected, right? Because of the query, these two nodes are connected. Now we can find out that how many nodes we have in this path, how many nodes we have in this path, right? And then we can subtract 1 because LCA will be considered in both the paths. So let's say we have X number of nodes in this particular path and Y number of nodes in this particular path. So we can say the answer will be X plus Y minus 1, all right? So now our problem is to find out LCA for the given two nodes. Okay, so now let's see how we can do that. Alright, so let's take this tree as an example, and we know that we are interested in lowest common ancestor. So let's see how we can find out. So let's take an example. Let's say we want to find out the LCA of 10 and 11, right? We want to find out the LCA of 10 and 11. So to find out the lowest common ancestor, we can try to track the ancestors of 10 and 11. So the ancestors of 10 and 11 are 1, 2, 5, and then we have 10, right? And for 11 we have 1, then 2, then 5, and then we have 11, right? So from this, can we say that we have 3 ancestors which are common in for both the nodes, right? And out of these 3, we are interested in the lowest common ancestor, right? And lowest means the closest to this particular, like both the nodes, right? So we can say that 5 is the closest, right? Or we can say lowest, right? Among all these 3 nodes. So because of that, we can say that 5 will be the lowest common ancestor for 10 and 11, right? And we can use the same idea to find out LCA for any node, right? We can, for every node, we can try to track all the ancestors of that particular node, and then we can find out that which are the common ones in both the nodes. So how we can find out the ancestors? Now that is the problem, right? Okay. Now the problem is that for a particular node, we want to find out its ancestors, right? Now we know that if we want to move from the root node to towards the downside, then we can do that by using this formula that for a parent, left child will be, for a like generic case, if we are at a node with value well, then the left child will be having a value of 2 into well, right? And the right child will have a value of 2 into well plus 1, right? So we can move from top to bottom using this formula, right? But can we move from bottom to top? Like if we are able to move from bottom to top, then it will be very easy to find out the ancestors of 10. Because if we are able to move from 10 to 5, then we can simply move to 5, then from 5 to 2, then 2 to 1, right? Similarly for 11, we can do that. But if we will move from top to bottom, then it will be a bit tricky for us to find out that where this 10 and 11 will lie, right? Then we might have to use some formulas to check whether 10 and 11 are present in the left child or the right child, right? So if we are able to move from bottom to top, that will be much easier. Okay, so based on this formula, can we somehow generate a way to move from bottom to top? Okay, now let us consider these two nodes, right? Let's say this node have a value of A and this have a value of B in generic case, right? So now let's we are saying that this whole value is equals to a. So let's say 2 into val is equals to a. This is what we are saying, right? Now we want to find out this particular value, right? We will have this value a and we would be interested in this particular value. So can we say that this val will be equals to a by 2, right? Similarly, if we just talk about this second right child, then we can say that 2 into val plus 1 will be equals to b, right? So now if we are interested in this particular value, then we can say that val will be equals to b minus 1 and then divided by 2, right? And if we are doing an integer division, then this whole value will be equivalent to, or if we just try to open this thing, we can say that it will be equals to b by 2 minus 1 by 2, right? Minus 0.5. So if we are doing an integer division, then this will be equivalent to b by 2, right? For example, let's say if this particular value is odd, let's say we have 3, right, which is a right child. So 3 by 2 will also give us 1 in an integer division, because if we will do a float, like if we are not doing an integer division, then we'll get 1.5. But if we are doing an integer division, then we'll get 1 only, right? Because we always get a lower bound, or we can say floor value, okay? Cool. So for 2 also, if we divide by 2, then also we'll get 1. So in both the cases, dividing by 2, we are getting the same value, because we are considering integer divisions only, okay? So now we can say that if you want to move from a particular value to the parent of it, then we can simply divide it by 2. So if we divide 10 by 2, then we will get 5, and if we divide 5 by 2, then we'll get 2, and if we divide 2 by 2, then we'll get 1. So these are the ancestors of 10 that we are interested in. Similarly, if we do the same thing for 11, then we will get like if we divide 11 by 2, then we'll get 5 again, and if we divide 5 by 2, then again we'll get 2, and then if we divide 2 by 2, then again we'll get 1, right? So using these two formulas, or we can say that if we are just doing dividing our value by 2, in that using this formula, we can generate or find out our ancestors for a particular node, right? And once we are able to generate the ancestors of both the nodes, then we can find out the lowest common ancestor. And once we have the lowest common ancestor, then what we have to do? Then what will be the answer? So in this case, we are saying that 5 will be the LCA, and the number of nodes will be equals to the number of nodes here and the number of nodes here minus 1, right? So can we generalize something here? Alright, now we are interested in the number of nodes that we have in this particular path and the number of nodes that we have in this particular path. So if the number of nodes in this path is x and the number of nodes in this path is y, then we are saying that the total number of nodes that we will have in this cycle will be x plus y minus 1, right? Y minus 1, because we are including this node more than once, okay? Cool. Now can we say that the number of nodes that will be present from 1 to 10 will be equals to the level that 10 is present at? So if we are considering this as level 1, this as level 2, this as level 3, and this as level 4. So all the nodes present at this level will have 4 nodes starting from root to this particular node, right? Okay. So now one more thing. Can we say that the number of nodes in this particular path from 5 to 10 is equals to the number of nodes that we have from 1 to 10 minus the number of nodes that we have from 1 to 5 plus 1. Why plus 1? Because if from this particular path, if we are reducing these many nodes, then 5 will also be excluded, but we want to include 5, right? So we can say that x will be equals to the level of this particular node. So we can say level of 10 and minus the level of LCA, and then plus 1. Alright, so x will be equals to this particular thing. Similarly, y will be equals to level of 11 minus the level of LCA, which is 5. So we can, instead of LCA, we can write 5 here, right? And then plus 1, right? Now if we just put these two values in this equation, then we will get level of 10 minus level of 5 plus 1 minus, plus level of 11 minus level of 5 plus 1 and then minus 1. Okay. Now let's bring these two values together. Level of 10 plus level of 11 minus, now we have two values which should be subtracted. So 2 into level of 5. Right, now we have plus 1 here, minus 1 here. So they both will cancel out each other, then we'll have plus 1 here. Okay, so this will be the final answer, or we can say this will be the equation that will give us the final answer. So for a generic case, can we say that this equation will be equals to the level of A, node A, plus the level of node B, minus 2 into level of LCA and then plus 1. This will be the final answer that we will have. Okay, cool. Now again we have one more problem, and that problem is to find out level for a particular problem. So how we can find out level for a particular problem? So one way is to that for the whole tree we can store the level for every node, but the number of nodes will be 2 power is to n minus 1, where n is 30, so 2 power is to 30 minus 1, and this will be equal to around 10 power is to 9. So we can't store these many values. All right. So now how we can find out level of a particular node? So can we say that the level of a particular node will be equal to the number of nodes that we have in this path and how many nodes we have? So if we start from any node, what we are doing? We are dividing that node every time by 2. So can we say that the number of nodes or level of this node will be equal to the number of times it will be divided by 2 until it reaches 1, right? So if we divide 10 by 2 once, then we'll get 5. Then again, if it is divided by 2 again, then we'll get 2. Then again, if it is divided by 2, then we'll get 1, right? So we can say that the level of this will be equals to 4, right? Because it got divided by 3 number of times and then it became 1, right? So can we find out the level of a particular node without dividing this until it reaches 1? So can we come up with some kind of mathematical formula to find out this particular value? So can we say that this will be equals to log of 10 base 2, right? What this value will give us? This value will give us 3, right? And then we will have to add 1 because we are using 1 based indexing. If we are using 0 based indexing, then in that case we will not have to add this particular 1. But if we are using 1 based indexing for this level, then we will have to use 1, right? So we can also take 0 based indexing. So let us just consider 0 based indexing so that we don't have to consider this plus 1. Now if we are using 0 based indexing, then in that case this will be the level of a particular node, or we can say level of 10 will be equal to this thing. Okay, so similarly we can find out the level of A, B and whatever will be the LCA, right? Cool. Alright, now let's try to summarize what we have discussed so far. So what we are going to do first thing that we are interested in is LCA. So first we will find out the LCA of A and B, right? This will be the first task that we would be interested in. After doing that, after getting the LCA, then we want to find out our answer, and our answer is equals to this particular expression. And in this particular expression, what we have to calculate? We have to calculate the level of A, level of B and the level of LCA. And for that, what we have to do? We have to use this particular formula, right? So then we have to use this equation, and for this equation we will have to use log of, we can say that the level of A will be log of A base 2. So after this we have to find out our answer, and our answer will be equals to log of A base 2 plus log of B base 2 minus 2 into log of LCA base 2 plus 1, right? This will be the answer, right? And to find out LCA, we will have to generate all the ancestors of A and all the ancestors of B, and then we can find out which is the lowest common ancestor, right? And for that we can keep on dividing A by 2 until we reach 1, and we can keep on storing all the values that we will encounter in a vector. Same thing we can do for B, right? So instead of using log every time, we can also use those vectors that will be generated while calculating LCA, right? We can use those vectors and we can find out the number of levels or nodes that will be present between 1 to the root node, B to the root node, and the LCA and the root node. Okay, so this is what we are going to do. Now you guys can try to implement this logic on your own based on these 2 steps. And if you face any difficulty while implementation, then you can ask your queries in the comment section, or you can also paste your code, and we'll be happy to reply on your queries, and we'll try to help you with the debugging also. So I think that's it for this video, and I'll meet you in the next one.